Today I'll talk about the multi-softmax architecture proposed for RNN-T models. They have two key objectives. One is to improve the multilingual RNN-T model, so they serve as a better seed model. Then we wanted to have a LID-free multilingual model. The LID-free models are the models which do not need to know the input language of the utterance during inference. So we propose to have a language-specific softmax, joint and embedding layers and sharing the rest of the parameters. That's our proposed model. We'll show that with our proposed model, we are able to integrate the LID model into the multi-softmax architecture. And what we achieve is a 12.2% word array reduction over the monolingual models. And the LID-free multi-softmax model also achieves a 13.86% reduction over the multilingual baselines on 4 Indic languages: English, Hindi, Tamil, and Gujarati. We have two multilingual baselines. One is a multilingual vanilla and a Onehot models. The vanilla model is a simple union of all the languages, and it's the data data from multiple languages are combined together, and similarly the output symbols are the union of symbols over all the languages. And the resulting network is trained as we train the monolingual models. The Onehot is a simple extension where a language-specific Onehot vector is appended to the input features and the model is trained. It is important to note that the vanilla model is multilingual, LID-free and streaming, while the Onehot model is not LID-free. The proposed model has a language-specific softmax layer, this language-specific joint layer and the embedding layers. Let us look at the results. The vanilla model is considerably worse compared to the monolingual models, while the Onehot model significantly improves over the vanilla. Our proposed multi-softmax model improves over the multilingual baselines and also the comparable results with an average improvement over the monolingual baselines of 4.65%. Now, when we use the multi-softmax model as a seed model, we see that the proposed model has a considerable improvement even over the monolingual models, with an average improvement of 12.22%. And also important to note that it is much better compared to when using Onehot as a seed model. The extension of the multi-softmax to the LID-free model is obtained by having an auxiliary LID model as shown here. During the training, the loss is a combination of the RNN-T loss and the LID loss. During inference, 4 different decoders or the beam search decoding is run, 1 per language in this case, and the output corresponding to the language which has the highest probability as obtained from the LID classifier is chosen as a final output. Comparing the results, the vanilla model, which is an LID-free model, and the multi-softmax model shows 13.86% averaged word error rate improvement compared to the multilingual vanilla model. And also the proposed model has improved LID accuracy or the ability to detect the language. So one challenge with the proposed model is that 4 different decoders of the multiple beam search decoding are running in parallel during the evaluation, which increases the inference cost. So we propose early stopping to reduce that inference cost. What we propose is that whenever the LID model says it is less likely to be language X, we stop the decoder X. So we maintain the confidence score for each language as obtained from the LID classifier, and whenever the confidence score falls below a certain threshold, we stop that particular decoder. Now, when we do this, we are able to reduce the number of decoders run from 4 in our case to 1.72. The average number of decoders to be running is just 1.72, with a modest increase in the word error rate from 21.84 to 23.14. So in summary, we propose a multi-softmax architecture which serves as a better multilingual seed model with 12.2% word error rate improvement over the monolingual baselines. Then the proposed LID-free multi-softmax architecture also shows 13.2% word error rate reduction over the monolingual baselines. Thank you for listening. Hope to see you at IndusSpeech 2021.